Hello and welcome to our lesson today on river processes, in particular the process of erosion. So what we'll do, our three key takeaway points will look at describing the different processes of erosion, to explain how and why they change along the river, and to try and link these processes to different locations along the river. Okay, so that's our aim for today. So first of all, a few things to think about. If you do have a pen and paper, probably best to get this definition down. But what is erosion? So erosion is a process where the river wears down its bed, that's the bottom of the river, its banks, and the sediment inside of it. So it's basically breaking down material, okay? In order to do this, it will need energy, okay? And this will change along the river. So the first two questions that we'll look at are, first of all, what do you think happens to the river's energy as we go downstream and why? So what happens to the river's energy and why? And the second question is, what might the difference be between vertical and lateral erosion? So what is the difference? What do you think the difference between vertical and lateral erosion is? So first of all, we will start with the top question. So what do you think happens to the river's energy as we go downstream? So from the upper course to the lower course. So ultimately, we are following this route of the river. We're going from here to here. So what do we expect to see happening to the river's energy? Well, first of all, we can see here the river is small, so it's narrow, shallow, so we can see that there's going to be friction taking place. That's what we can see with white water. So therefore we can assume safely that there's low energy here. Okay, now if there's not much energy, then we can presume that not much erosion can happen because it needs energy to break down material. So it's low energy, so there will be less erosion taking place. Okay, so less erosion taking place. So therefore, if we switch over and we'll go to our picture on the far right. So on the far right, what we're looking at is a river that's basically the opposite. Okay, from this visually, this is the lower course of the river. We can see that the river is wider. We can presume that it's deeper. We can't see any white water, so we know that it can't be shallow. And therefore there's less friction, and with that bigger volume of water, there'll be more power. So more volume, more power. So we're looking at a river that has more energy. So this river channel has more energy. So therefore we can assume that more erosion could take place here. Okay, so we've got these assumptions so far, okay, which is all absolutely fine. So what we're going to do now is now we have had a little look to see how river's energy changes downstream, and this often links to the Bradshaw model, which we can see right in the middle. So we'll see that that can match. So we got this triangle showing discharge, where that triangle has a smaller point upstream, which shows a smaller discharge. That's the volume and speed of water combined. And we can see that as we go downstream, the edge of that triangle gets bigger, which shows that our discharge is also getting larger. So we can see that literally our small triangle here for upstream and is much wider here for downstream. Okay, and we can see the same things wider, it's more narrow here. Okay, these same differences are happening. So river's energy increases as it goes downstream. Okay, so we'll come back to that reason why in a moment. But our next thing that we'll look at is what might be the difference between vertical and lateral erosion. So vertical is this is basically going up and down. Okay, vertical is going up and down. So if you were to drop a ball vertically, it would fall. Okay, so vertical erosion, I'll just put an arrow next to it, is down. Whoops, we'll make that an arrow. It's basically downwards. Okay, lateral erosion, it's a little bit different. Okay, so laterally means sidewards. Okay, so lateral erosion is this sidewards erosion. So this is another form of erosion that will change. Now, when the river is in the upper course, its aim is to get down to sea level. Therefore, the river, and we can see visually there, actually, I'll just amend that. So we'll get an arrow. So our river, we can visually see that it is cutting downwards. It's literally is falling. There's a mini waterfall there. So we know that vertical erosion is happening because the river is cutting downwards. So vertical erosion is happening because the river is cutting downwards. Okay. It's trying to get down to sea level. So if we go to our other diagram, we can see here it's not cutting downwards anymore, but it kind of bends, it meanders, it changes shape. So here we can see that actually it's not cutting downwards, but it is eroding laterally. Okay, so we'll add this in here. So we say lateral erosion. So it's this sidewards erosion is taking place as the river is near to sea level. Okay, so all of its energy that is used cutting downwards is now changed to erode sidewards. Okay, so what we'll do is we'll try and put together a reason why is this change happening? Why is this small river changing to the big river? And that comes down to this picture right at the very bottom. Okay, so this picture shows two rivers meeting. Now, if you look at this, you'll see that when these two rivers meet, we'll just add a little arrow on here. So we've got one stream this way, one stream this way. At that point where they meet, which is called a confluence. So this is called a confluence where two rivers meet. We can see that the volume of water is basically amplified. Okay, so the river becomes wider. This increases the supply of water in the river. Okay, and we can see that it will continue on its journey, but at double the amount of water. Okay, so at a much higher rate. So every time a small stream meets another one, the volume of water gets bigger. So along the whole river's journey, there could be over 100 points where little streams meet bigger ones, and that water is merged. And that's how we go from a small river channel to a much wider, larger river channel. Okay, so what we're going to do, let's pick out some of these key processes that could happen along our river course. So it comes down to four key forms of erosion that you need to be aware of. So this comes down to these four key terms: hydraulic action, and there's a picture showing what that looks like. So you might find cracks in the banks and bed of the river. Okay, abrasion, which we can see at the bottom, which is linked towards the piece of sediment at the bed of the river. Attrition, where we can see finer sediment floating in the water, and we can see solution, which is kind of clear. Okay, there's nothing really showing that. So from whoops, sorry, I'll go back again. From the pictures and from those key words, you can have a little look at these definitions to see how you think they would match up. So we got material is dissolved, sediment in water is dragged against the bed and banks of the river. The sheer power of the water wears down the bed and banks. And finally, sediment is knocked together, becoming smaller. Okay, so first of all, we can work out some of our easier key solutions here. So in terms of solution, we know we're looking at dissolved material, and this key term is also used in erosion in transportation as well. Then we can find attrition. This is basically where the sediment is floating, and we can see, I'll just remove that one. We can see that that sediment is floating, so actually it's the water holding that sediment, and it will gradually get knocked together. Okay, so that is this definition here. Now abrasion, we can see that sediment right at the very bottom, and this is to do with sediment being dragged by the river against the bed of the river, the bottom of the river. It can be the banks as well when the river is powerful, and it will abrade or it will scrape away that river channel, okay, making it much wider and deeper. So all of these require energy, just something worth bearing in mind. And then we've got hydraulic action. Hydraulic action, just like the hydraulics used in machinery, these are basically powerful things. So it's the sheer power of the water wears down the bed and banks. Okay, so hydraulic action, we can see those cracks forming. Is the power of the water colliding into the sides of the river that erode it and wear it apart. Okay, so these are the definitions that you need to know at GCSE level, and these are the ones that we'll work towards using. Okay, so what we want to do is go on to identify what could be happening, what forms of erosion could be happening, and where. So we'll leave this diagram up so you can have a chance to reuse some of these terms. Okay, but what we are looking at, which form of erosion might we find at each image? Okay, so think about your definitions that you looked at. Think about what we can see in those images. Okay, so first of all, I might say, well, there's a lot of water falling there. It must be pretty powerful. Okay, I might make an assumption that the water here is quite clear, therefore we might not see too much inside of it. Whereas the water here, we can see that it's murky. Okay, we can see that it's also quite powerful. There are small little bits of sediment, pebbles along here. So we can make an assumption on what kind of processes could be happening. So obviously this varies across different parts of the river. But first of all, if we see that water that's falling down at the waterfall, it's really powerful. That might show us a form of hydraulic action. It's the power of the water falling, which is basically eroding away, wearing away material, or in this case, a plunge pool. Okay, so hydraulic action could be happening there because we can see a powerful water. Okay, if we use the same idea, okay, here the water looks clear. So maybe we can assume that it could be solution. Okay, in theory, solution could happen at all parts, but if we were to put together an assumption, we could assume that there might be some dissolved material inside of it. In theory, solution, because we're not going to see it because that material is dissolved, it could happen in all parts of a river. So if we continue So first of all, that first arrow, which shows that brown murky material. So that shows that we got material that is hovering in the water, okay? So that could potentially be attrition, because material is suspended in water. So that gives it this brown murky color, okay? So it could be colliding together, chipping away and getting smaller. We can potentially make that assumption. It could be really, really fine sediment. It could also happen with larger sediment, and we can see that sediment, the size it can get to on the side, okay? So potentially we could assume that it could be attrition here. We can also make an assumption with our other arrow. Well, looking at the side of the sediment on the banks of the river, we could also assume that abrasion is taking place. So material is scraping along the banks of the river. And potentially what we can't see are also the beds, or the bed of the river. Okay, but we can't see because the water is murky. So a lot of this erosion is, you need to assume it, but we can use it on certain points of evidence. Either way, hydraulic action, we can see powerful water, okay? With attrition, we can see there's sediment in the water, and abrasion, we can also see powerful water, so we assume that it's going to be moving that sediment right at the bed of the river, okay, scraping it along, wearing away the bed of that river channel, which ultimately makes the river deeper. So if we clear that, and we'll have a look at one more example. So this is geared towards what we might be seeing again here. So we'll tie it back to our original ideas. So here we can see that the river is definitely dropping down. There is not much energy in the water, so there might not be much erosion happening. Maybe a tiny little bit there, but not much is happening. Here we can see the water, well, it looks pretty clear, okay. We can see it is much wider, much more energy is here. But then we also can see this movement, it's no longer cutting down, okay. So in theory, what we're looking at here, we're looking at vertical erosion because the river is cutting downwards. Whereas in our other one, it's nearer sea level, the land is flatter, therefore lateral erosion, sideways erosion is taking place. Okay, so if we continue, so right at the bottom, so this can be matched with both. I guess if there's clear water, we could potentially argue that solution is taking place. And this idea can be matched over here. We can't see, the water isn't looking murky, so clear water could mean that solution is taking place. Okay, now what we can assume in this bottom picture is that it is powerful. Now we won't be able to see any material inside the river. We can't really see anything floating in it. We can't see the bottom of the river, but we can assume from our little Bradshaw chart right in the middle, discharge and velocity of the river is high. So therefore we can assume that hydraulic action could be taking place because the river's energy is high. And that will typically happen at the edge or the outside of a river bend. Okay, but that's another lesson when we look at landforms. If we look at the image on the left, we can see that there is a drop in water So we could also argue there is that drop in water creates power, which could lead to hydraulic action happening there before our eyes, just at a much smaller scale. Okay, so that could be happening right at this point. So ultimately, these different forms of erosion can happen at any point, but ultimately where there is more power, so downstream, that's where you're going to find more erosion taking place at a much higher rate. So we'll clear this and we'll end with a little summary. So ultimately, we've got 4 different processes of erosion: hydraulic action, which is the power of the water; abrasion, which is the sediment wearing away, being dragged along the bed and banks of the river; attrition, which is sediment basically floating in the water and being knocked together. We've got solution, which is material that is dissolved in the water. Now, how and why do they change along a river? Basically, as we go from source to mouth, there's a transition of energy. So it starts small, the river tends to be more narrow, and in the upper course, vertical erosion is taking place at a slow rate, but it's taking place as the river is trying to cut down to sea level. Okay, as we go along the river, it meets other rivers through a confluence, and that energy and that volume of water is amplified. So therefore, there's potentially more power for the river to erode more. Okay, so erosion increases, the speed and volume of water increases. So as you go to a much wider and deeper river nearer sea level, or the lower course of the river, you're going to find lateral erosion taking place because it no longer needs to cut down to sea level. It's very near to that point, so all of that energy is transferred laterally instead of vertically. And finally, we want to link processes to different locations along a river. Ultimately, the upper course, we're going to find vertical erosion for sure, because it's trying to cut downwards, but it's going to be low energy forms of erosion and a much lower rate of erosion. Whereas the lower course, we're looking at lateral erosion, so sidewards erosion. It's going to have higher energy because it's got a bigger discharge, and there is ultimately more or a higher rate of erosion in the lower course. Okay, thank you very much for listening. Have a lovely day.